In an earlier video, I cautioned against assuming reusability is cheaper than expendable rockets. Reusing rockets and their engines is the lowest cost way of putting things in space when considering the rocket by itself. Rockets, of course, do not fly by themselves. The Blue Origin New Glenn rocket lands downrange of where it was launched, on a barge in the Atlantic. That means New Glenn does not need to carry the fuel needed to fly back to where it was launched. That also means weather in the Atlantic is a factor in deciding to launch, and there is the cost of building the remotely operated barge, buying another blue water ship for controlling the barge, and the crew and maintenance and fuel and docking become part of the cost of a Blue Origin launch, if it all works. SpaceX, who've got experience with dozens of Falcon 9 missions where boosters were recovered on barges out at sea, are trying to eliminate the ships and their costs by catching rockets with giant chopsticks attached to the launch tower. That means the Starship booster has to carry enough fuel to fly back to a launch tower. It also means a failed landing is likely to cause serious damage to the launch tower. Establishing a record of reliable landings of the upper stage of Starship is even more critical, or Starship can't be human-rated. Any design that counts on landing a booster means the booster has to use more expensive rocket engines. They need to be pump-fed so that they can be deep-throttled, so that they can land gently and accurately. This is a good example of how the consequences of design choices ripple through a system and through the project plan for building that system. A more complicated set of interlocking requirements and the design and testing time needed to make those work also add cost to a rocket. Are we still cheaper than the less glamorous, expendable rocket? Blue Origin made the decision to rein in their ambitions of reusability and build an expendable upper stage. SpaceX, however, committed to using a reusable upper stage. This raises the stakes considerably. The combination of the seat-of-the-pants iterative project management style and critical dependencies in the project will, by Flight 7 of this supposedly cheap rocket, cost the expenditure of 273 brand new Raptor engines, which are the highest performance pump-fed engines ever built. Just a few more iterations should be needed to prove that reuse of Starship boosters works. It shouldn't cost more than a couple of $1 billion in engines thrown into the sea to get there. And then SpaceX can start iterating towards a human-rated upper stage. Still cheaper